and materials. We welcome our chair session on the dais. Today's let us welcome today's first speaker, Dr. Daisy Joseph from BRC. She will be speaking on the topic unraveling problems in materials via X-ray emission techniques using probes such as photons, protons, and synchrotrons. So today I will like to request the speakers. After that, the mic will be with Vijay sir. That you please focus on to the applications on the topic on which you are speaking. Dr. Anuj and Madam and Sir again, although Sir will be speaking on the very basic things of the science teaching. He will relate it with materials and thermoelectrics also, so that it can be useful for Wing Commander Yogesh and Wing Commander, good morning, welcome, Dimna. They are here from Air Force to witness and to extract the gist of this conference, so it can be used in the defense sector of our own country, India, to develop indigenous equipments and technology, so that we can be self-sufficient in terms of development of technologies and equipment for the defense applications. So with this, I request Professor Vijay sir to take over the proceedings.
नमस्कार सभी को। एक शुरुआत कल काफ़ी अच्छी हुई। We had a very good introduction from the Chancellor of the university, and his vision is clear that he is interested in the youth of this country to get maximum benefit from the seniors or the researchers who are doing good for the nation, so that they come on the track. Okay, they are inspired by the seniors, whatever research they are doing, how they can add on the research and the theme gets multiplied. The indigenous research should take a shape, and well, our even the defense colleagues are here. They are making use of imported missiles, aircrafts, and even most of the material. Okay, so can that be converted into indigenous? Okay, of course, they are doing wonderful thing at DRDO, Defense Material Research Lab, and so on. Okay, so at student level, here you learn through this platform what researchers are doing and which can be used or integrated in your studies. Okay, and how to integrate? This is the task of these experts who spend a lot of time. So today we have a very wonderful woman scientist from Bhava Atomic Research Center, BARC. She is a product of Bombay University, and she has served, and probably recently she has retired officially, but never tired. Okay, and she's looking forward to much more academic activities at different institutions, and that's why she's here. She has a credit of 150 plus publications in international journals. She has worked with the beam of photon, beam of proton, beam of X-rays, okay, uh, from the synchrotron radiation we call at, for characterizing the material properties, okay, and a couple of PhD students are produced from her guidance from BRC, okay, a successful journey, and that is what she is going to share with us. I am glad to interact this morning also with ma'am. We welcome you, ma'am, and eager to listen to you, okay, how was your journey to BRC within 5 minutes, and then the academic part, and then certainly 5 minutes, if the chairman permits. She has a very good sound, okay, or the music in herself, okay, that instrument she carries. So probably we like to enjoy a part of it. Thank you. Please, I just sit there.
A very good morning to all of you. I hope you have the energy to listen to my talks, and I will never make it boring because I also was a student at a time in Bombay University when all were pursuing a lot of other lines. I was very particular. I did MSc by nuclear physics. It was electronics, solid state electronics, and solid state physics, and all kinds of physics. But I don't know, the accelerators fascinated me. And they said I must do nuclear physics. And my destination would be BRC and TIFR. So I worked in both the places, and I realized there's so much which we do not know. We only read in books. When you actually deal with the instruments, we realize the basics of physics. Today I'm going to share a lot of basics, and as Dr. Sharma said, that the applications are there. I first of all thank the organizer, Sharma ji, for inviting me, and I'm here to interact. And I want the students to interact even during the lecture or after that. I will definitely help you all in any possible way because I know the students who have come to me, I have seen they have got good number of publications, they have got their PhD, and they are now settled abroad. Uh, I don't know, I was not here when that Korean scientist has come. Korea is a place where they need students for research work. So there are a lot of institutes which welcome the PhD and the postdoc students. Do your work passionately. This is what I would advise. And before I start my lecture, I would also add that why did the song win an Oscar in the Oscars competition? Does anybody know? Why did the song Natu Natu win the Oscar? Yeah, because it was original. What I mean to say, there is no point in cutting and pasting somebody else's work. Be original and don't be afraid. Think of an idea, carry it out, and be original. You will be appreciated. And definitely, I also started as an assistant in BRC. I was working with the stripper foils of the Peloton accelerator in TIFR. Then I went on to work on my own and work hard. This is very important. All are observing you. Professors, colleagues, everybody observes a person's sincerity. Sincerity and passion and loyalty. Keep in mind, trustworthiness. These are some of the values which students have to be imbibed, and no faking. With the social media, there's a lot of faking around. No faking, no cut pasting. Be original, be passionate, be loyal to your work, and that's what is required for an original research work. Okay, now let not bore you with all these uh, things. So let me go on with my lecture. My topic is, I hope it's not difficult, unraveling problems in materials via X-ray emission techniques using probes such as photons, protons, synchrotrons. I will explain to you what does all this mean, like what is this proton, photon and synchrotron. So I'll have to change my slide on my own, or can anybody help me? Please, please. So what are the variations of X-ray? You have X-ray fluorescence. Like I will explain to you what it is, which is ED, that is energy dispersive X-ray fluorescence, wavelength dispersive, total reflection, micro XRF. I may go a bit fast because I need time for the latter slides. Now, proton-induced X-ray emission, synchrotron-based exapse and exanes, and the lastly is you have the handheld X-ray fluorescence, which is a present instrument I'm using in BRC. I was using, but I still have access. Next. So if you go to the electromagnetic spectrum, you see where the X-rays lie. It is here between ultraviolet and gamma rays, and you see the frequency and the wavelength. Okay, so this is the region I will be dealing with my techniques because we need to analyze the element. How I'll do that, I'll show you. Next. So this is exactly what it is. So you are dealing with energy such as 0.125 kV to 125. It's a big region, but it's a kV region. Okay, maybe you want to gamma rays, and that is a different technique. You have gamma ray spectroscopy, which is done by many groups. Next. So basically, what is the X-ray emission? It is a source of X-ray. It could be a radioisotope source, it could be an X-ray tube, it could be a synchrotron which strikes an inner shell electron from a sample. A high energy, which is above the absorption edge of the element, is ejected. The electron is ejected, then the high energy falls down to the vacancy which is created, and it gives out characteristic X-rays. Why characteristic? Because elements are distributed in different discrete energy levels and they have an energy difference which is seen as an X-ray, characteristic X-ray, which is defined for every element. For Fe you have 6.4 kV. I know the whole periodic table and the characteristic X-ray energies with 37 years of experience in BRC. So I can, by looking at a spectrum, I'm able to tell what elements are there in the material. That is how it starts. So we are talking about materials. Definitely any researcher would like to know what the composition of the material is. So they come to me, and there were cases when people have purchased foils like platinum, which is supposed to be very expensive. They come to me and I found it was Fe, not platinum. So they were cheated. So that is how one has to start with the material. You should know the composition, then proceed with your research. Next. Next. Okay. So variations, as I told you before, you have excitation source, radioisotope, X-ray tube. W, we have wavelength, goniometer, tube, Peltier cooled X-ray detector, SDT. Now Peltier cool avoids the liquid nitrogen filling thermoelectric property. So it is suitable. I can refer to the topic of this conference which talks about thermoelectric. So with that principle, you have the Peltier. I worked with all this except the WD. Then you have the handheld, which is again a portable in which the window is graphene. I'll tell you the difference. In general X-ray fluorescence, we use semiconductor detector, which uses a beryllium window. Beryllium window absorbs the low energy X-ray. We are unable to detect the aluminium and lower Z phosphorus sulfur. But with handheld XRF, because the window is graphene, you can characterize the phosphorus, the sulfur, and aluminium, which is very important. Many materials. Now materials are coming up so much, especially aluminium related materials. Next. So this is the machine we have in BRC. Most of the machines in the market now, XRF is ready-made. It's portable. It's easy. But when it is spoiled or when it is not working, you have to depend on the service engineer. It was not so in my case. We had assembled this in BRC. You have the radioisotope source, which is a ring source. It strikes the sample here. You have the backscattered X-rays, reflected X-rays falling on the window or beryllium window of the detector. Detector is only this much. What is left is the debar which carries the liquid nitrogen to make it cool for several reasons. To discard the noises and all that. And here you apply a high voltage of around minus 800 volts to be practical, and which is again amplified and shown in a multi-channel analyzer which is PC based, and you have the data. Please tell me the time if I'm too slow, or is it okay? So you have a data which can be stored for offline analysis. Next. So I'll just brief you to some of the source which BRC has, and I have dealt with Fe55, cadmium 109, americium 241. We have all these, but I have dealt only with the first three ones. This is for the medium Z because it can give an emission of 5.9 kV. So which anything less than this can be detected, the low Z, cadmium medium Z, and americium the high Z, because it is 60 kV. It gives out, so anything below 60 kV. So some of the geometries I have here. You have the annular source, pessimism is in front. You have the point source. So these, the efficiency or the detection limits are different. So mostly we use this geometry. Points also, source also we have used. This is the side source. You keep it at the side, the point source. You get better resolution and better analysis. Anyway, it is just a variation. Next. What exactly is PIXI? It is particle-induced X-ray emission. The particles could be protons or alpha particles. Next. So I just wanted to add a sample preparation. Now, PIXI is generally, I would show you the X-ray absorption cross-section of these two techniques. XRF is connected with the photons, and PIXI is protons, proton-induced X-ray emission. So PIXI is good for the low Z element because the cross sections are higher. I'll show you the graph. I don't know if I have brought it. And the photons, XRF is for the high Z, the rare earth elements, if you know the periodic table. So all samples, like if you have a powder or if you have a tissue, it can be freeze dried using liquid nitrogen, and if it's something biological like blood or tissue, you have to digest in this concentric acid, HNO3, and then you can micropipette it on a target, which is 5 to 10 microliter, and go to a proton beam for irradiation. Next. So this is our schematic diagram of the folded tandem ion accelerator, which I used it, and I did my PhD on this. So here you have the source, the ion source, the beam goes up, right up. Here you have the stripper foils. It strips the this of negative ions, comes down as a positive proton beam, and here you have the PIXI chamber where the samples are mounted, and we analyze it and we get the characteristic spectrum. Next. So here you have the electronics is almost the same. You see the setup. Everything is same except it is in a chamber, and there is this. I would have shown you the difference, but I can as well tell you that for photons you get 10 raised to 8 photons per second. In protons you get 10 raised to 12 protons per second. This is the flux. I mean, it's better. And for synchrotron, it's much better. 10 raised to 17. So depending on your problem, you can use your beam. And there are facilities in BRC. At least I have used it. If you can interact with me, I'll direct you to the right person, and they will, even for synchrotron, I will come to it. It was in RRCAT indoor. I used to send the sample, and they have done the analysis for me and given the results. Next. So here energy is used is 12 MeV. For alpha it is 66. For pixie we need a current of 10 to 20 nanoamperes energy, 2 to 5. Otherwise your samples will get burnt. So it has to be on the lower side. I have worked with 3 nanoamperes also, 7 nanoamperes also. And energy I used to work with around 3 MeV. Next. So this is the spectrum I was telling. So with Z, your ionization cross section for photons is an increasing function of Z. Here you see 60 kV, which is americium, cadmium, Fe, increasing function. So it's good for high Z elements. Whereas for protons, which it is a decreasing. So it is very good for the low Z elements. Okay, not so good for the high Z. So they are complementary techniques, and I used to get samples. I used to use both XRF and PIXI, and that is how I could publish very beautiful papers on XRF and PIXI. Next. So some of the basics I am going to. I don't know if you have heard of physics students. I must have heard of the detectors, the silly detector, pin diode, silicon drip detector, SDD, proportional counters. These are all come probably in MSc portion also. Next. So here you see what it is. It is a crystal basically. Here you have the preamp, the devar which has a liquid nitrogen, and you have the detector. The window is beryllium or polymer, and of course you have to fill the liquid nitrogen, and the counts are around 3000 to 30,000 CPS. Next. So this is a photograph of where I used to use the folded tandem ion accelerator, and this was a big devar, the detector, silly detector. The probe was kept. This is the pixie chamber. This is the ladder which goes up and down for fixing your samples, and the beam comes from here, strikes on the sample, falls on the detector, and all the rest electronics are just like XRF, and you get an output full of spectrum which you can analyze. Next. So some of the application, the bioscience, plant, soil, blood, Ayurvedic product, coffee samples, dental powders, environmental, etc. I have also worked with actual materials, doped materials, and several other materials. There is not a single division in BRC. You may check it out with anybody who has not collaborated with me. Everybody has collaborated with me, and they know samples come to given to Daisy madam. The results will come next day, in one day. I never kept anything pending. That is how I got some beautiful research work and publications. Next. So this is one of the investigations of mercury and other heavy metals in Indian Ayurvedic medicines by EDXRF. So of course, Ayurvedic medicines are recommended for everybody, but they do add heavy metal for the processing, and the thing is that it has to be excreted or removed from the body. Otherwise, it is dangerous. That is why you have regulations in food. You are not supposed to eat this or eat that when you take Ayurvedic medicines because of this heavy metal presence, and it has been seen. We have seen mercury, L alpha, L beta. These are the three peaks we have seen, and probably little of arsenic. And so that is next. This was in collaboration I have done with a Bombay University student. Okay, so these are some of the herbal medicine names. Next. So if you see that I marked in red the counts which are obtained of XRF of Ayurvedic sample. Next. So the conclusion is that they do contain, but it needs to be tested, and also we need to do a clinical study of how the person takes it for a long period of time and check their blood or urine for the this. It was published in International Journal of Pixie. So when I started doing Pixie, I've done my PhD in that. There was a journal called International Journal of Pixie. Most of my papers were in that. I stopped doing Pixie, and they have stopped the journal. And I was feeling sad why they did that. The youngsters would have as well published it. But they stopped the journal, and it was published. And I have several papers in International Journal of Pixie. You can always Google it out and check for yourself. Next. So this is blood lead levels in children from Dharavi slums by Pixie. Again, it was published in Science of Total Environment. So why this blood was taken from children of slums, because there was a doctor from KM hospital and he was doing his DM using the study of the children. The children had the habit of eating mud from the roadside, and there were a lot of traffic passing on the uh, road. So the petrol had lead. That is how probably a lot of investigations led to the unleaded petrol. So the government decided that one has to come out with unleaded petrol, because lot of symptoms were seen in the children of blood poisoning. Blood poisoning means the word looks harsh, but the symptom is the children are not having hemoglobin. That is the first sign. Anemia. Anemia is the first symptom of this kind of blood poisoning, and lead poisoning. And another thing is, because of the lack of Fe or the anemia, the children are mentally retarded. And that is the first symptom. I will show you the different categories and which category has the maximum lead. So it was using Pixie. If you see here, you have the lead, peaks, alpha, beta, which is, and all the others, the low Z, potassium, calcium, etc., which is necessary. It was seen. It was compared next. So if you see the table, so you have all kinds of hypothermic anemia, so gastro. These are the symptoms of the anemia. And next, see, here the international average is around 0.21 and 0.3. But all the showed 2, 6, everything. If you see the lead, this is the last column for the lead, and 2 is quite high, and 6 is high, 7 here you have. So some of the variations as compared to the 0.21. So definitely lead above a certain limit is not good for the human body, for the blood. So why people are worried about the heavy metal or the toxicity? Why is it called heavy? Because of course high Z, no doubt, but it's, and for the blood it's not good, and it cannot be removed, and the person starts having problem with many skills of the body. See, many times if you notice, nowadays it's becoming very common that there is stiffness in the body, isn't it? So you should check your hemoglobin, should check if you have some toxic elements in that. My technique is a diagnostic technique. It tells you what's there in the body, and there is a very good books on telling what are the limits of trace element supposed to be in a human body or in a living organism. So once you follow that, and once you do the study or take interest, it's very interesting, really. My topic, you can deal with the environment, deal with the human body, and deal with anything, milk, food products, anything. And I am not boasting. They have globally found out who's doing so much work. I'm the editor of a book called Trace Metals in Human Health and Diseases. It is an open access, in-tech open access book. You can also go through it. Probably it's for purchase also, but online it's available. I can send you if you want. I'm also the editor for the book Trace Elements in the Environment, which is probably they have selected me by going through the kind of publications I've been doing. So it's very easy to talk about pollution, very easy to talk about toxic levels or toxicity. And now presently in Kochi there is some water plant which was burned, and all the toxic fumes are in the air. So first of all, you should find solution. Heavy metal presence is not advisable, and if you go through that book, I will recommend it, probably email to everybody, that in that there are certain limits which you have to follow, and if it goes above, you have to be careful, that's all. So many of the, even the packed, I'm doubtful about packed milk also. Packed things you have to be careful. They add preservatives so that it will preserve for a long time, and that will be carcinogenic. So one has to be careful. Everything natural is always advisable, and it's good for the body. Next. The next study is, no, next, first one. This study is also uptake of uranium by cyanobacterial cell, marine separation. This is the most cited paper I had in collaboration with microbiology colleague of mine. She's a scientist, Selena Acharya. She came to me and she said a lot of green funds are released for bioremediation. What is bioremediation? Is naturally removing the uranium and the heavy metals through natural means, like through algae or through bacteria. So cyanobacteria cell is generally, it is hard to uptake or absorb the uranium. And that I saw using the XRF. Next. So what was done, they were grown in this nitrate and carbonate and determined for their uptake using cadmium 109 induced EDXRF. It was found that elements such as potassium, etc. were present. Uranium was present in significant. After 2 hours of uptake, it became saturated after 5 years. So, what I mean to say, many reactors have uranium and how it has to be removed. So, if you have the algae cells or bacterial cells growing around, this uranium will be absorbed by them and it is a natural way of removing it. If you, otherwise you have to look for very alternate expensive methods to do that. Next. So here you see the spectrum, you have the count, 6A, and you see CFE is present zinc, but uranium is there in a large quantity, L alpha, L beta, L gamma, beta 1, beta 2. So you see the, this is in 2 hours, next. So the conclusion is in 5 hours it was getting a plateau and all the uranium was absorbed. So this kind of bioremediation is very advisable and BRC has been coming out with good funds for this work. It's a useful work, no doubt. So I have used handheld X-ray fluorescence to analyze Indian green and black tea leaves. Next. So this is the handle. It is like a gun. I have been pressurizing my seniors to buy this because in the other XRF I had to fill liquid nitrogen, which was very difficult in such a big diwar, 16 liter, and that would be my work to get good resolution of the detector. So that was a very difficult thing which I did almost for 20-25 years, and then they said no, she is getting older, she needs to get a small detector, which is a silicon drift detector, and it has a graphene window to detect sulfur, phosphorus, aluminum, which is not possible in conventional. Next. So 28 elements were detected in black and green tea leaves. They showed presence of some rare earths. And to understand the differences, which tea leaves are more, it was found that black tea leaves showed greater presence of elements than green tea. That's why green tea is recommended. Because tea leaves, all natural products or plants do have a lot of potassium, calcium, manganese, Fe, they do have. Why banana is recommended for fruit? Because it has a large amount of potassium and calcium. One needs to know that. Through my research, I have seen it. So, all that. Even green tea is recommended. See, during black tea, what happens? There is some processing which takes place. So, it robs the elements. So, green tea is recommended for, especially for girls to become thin and all that. First of all, without milk, they are using green tea. And that green tea has some very good original this of the trace element. That is the main reason. Next. So, this is the table if you see in ppm how it is. If you see here, see the calcium, potassium, actually, yeah, they are all on the higher levels and the others on the lower levels. Next. Now, let us go to synchrotron radiation, which I had access because I was in the physics division, and synchrotron accelerator, BRC, DAE has spent around 300 crores. So, it is open to students. If you all open that website and apply for the beam, it's available online. Apply for the beam and putting a collaborator of your professor, definitely they will entertain you. But you have to find a good problem, search for a good problem, find out what you can do, what exactly you can do, And they will definitely give the beam time. Go there, maybe in a week or so your results will be out. It's not a very difficult thing. And I had, maybe I have around 10 papers using synchrotron. So it was, I was always finding new ways, innovation for bettering my work. How long can I do XRF and Pixie? So I thought I will do synchrotron since the facility is available and you get different results and you get a micro beam, you get a beam of 10 raised to 17 photons per second, which is a high flux, and you can analyze your element or variations you can find where this, see this facility is not available around the globe. It's not. Very few countries have. Maybe we are within 5 countries who have synchrotron. So let us consider India a privileged country. We are not that poor. We are rich. We are very rich in science. We are the best scientists. I am telling you, if you go for research and see who does science, Indians are first. They do science in a very nice way, in a religious way, duty-bound way, and they get good results. We do not know how much exposure they get for publishing their papers, but now the Oscars have shown it. Original has value. Be original, do good work. Use the facility. Write to the scientist directly. If you are not, don't talk to low people. Talk to the topmost person. They will help you. They will call you. They will ask you. And especially ladies, please. I am a lady myself. And I am telling you, do not lose your hope or do not give up. Always keep it up. Take it as a challenge. Life is a challenge. You may have a lot of problems. A lady has problems every day. Every day. Biologically, mentally, physically, spiritually. She has a lot of problems. Pray to God and never give up. One thing. Second thing, take it as a challenge. And your parents may force you. Marry, marry, marry. Your next work is to marry and produce children. Ladies are not only baby producing machines, they have brains. And there are people who are gone into schizophrenia. Why? Their work was only to produce a child. And then what happened to the brains? Nothing. They just have to cook and serve the family. Don't do it like that. See, parents expect something from you. I was the youngest of 4 girls in the house. I was the boy of the house. So I never disappointed my father. He used to get scholarship for my marks in SSC. And so I never minded. Physics, nobody takes. Ladies don't take. In my division, in nuclear physics division, there are only 2 girls. 2 or 3. One is unmarried and one is, I think she's married. She's having 1 daughter. I was the one who was doing my homework. My husband was abroad. He was abroad for 15 years. And I was raising my children all on my own, traveling 4 hours a day, 2 hours up, 2 hours down to BRC and back. So I used to take it very, very seriously, my work. I would not waste a single minute. I would take lunch for 10 minutes and keep reading. Keep seeing how I can do better, how I can. My children were raised in the best way. My daughter, she's MSc Geoinformatics and she is a system analyst in Auckland Council in New Zealand, which is a government firm. She's doing very well. Her maps come in on TV, Google Maps. And my daughter is a lawyer. My son is a lawyer. He's LLM. He's pursuing his PhD in law. He's a professor in a college in Bombay. So this is it. They have always said, Mummy is our model. I wake up at 4 and that's how I start my day. And you see that, what I always feel, this time is not going to come again. Correct? We all have 24 hours a day. How well you use it is important. But I have seen youngsters wasting their time, always on the mobile. Always. It's very, very bad. Use your time. And I heard somebody say, if you kill time, time will kill you. Isn't it? So, always use your time. We have a very short life, very short life. See, I am 60. I may not look. I was very active in my young days. And I continue to be active and work till 80, 90. And I And if you can contact me, I'll be the first person to tell you where to do what. Because I was all alone. Because I was a woman in BRC. No, I have not finished my talk. There are lots of synchrotron, lot of beam to come up, and though they clap their hands. So what I'm trying to say is, a woman is a fighter herself. Do not depend on anybody. Sometimes you say, oh, my mother will help, my daughter will help, my that one will. Nobody will help. You know yourself, you know your body. Take care of yourself, isn't it? You are responsible for yourself. That's all. Next. So what is exactly this X-ray absorption? So we were talking about the characteristic X-ray, which is a reflected X-ray. This is absorption. It is often referred N. N is near exaphs for low Z elements and exaphs, which includes Zanes for intermediate and high Z. Next. So when an electron traveling at nearly the speed of light emits a continuous electron spectrum tangential to the orbit. Next. That is, before that. You get a synchrotron. Next. So how does the spectrum look? Here you have the absorption, X-ray energy. So if you see, when you talk of edge, this is the edge. You are measuring the absorption edge. Okay. So just beyond that is the X-ray near emission spectrum, near edge spectrum. And here you have the exaphs, the extended X-ray fine structure. So near the edge you have Zanes, little far you have extended. Next. So you, as I told you, it is raised to 17, high brightness, polarized, tunable, no sample preparation. Next. I had done some pottery samples, which is again brought to me by University in Telangana. Next. So here you see the pixie and X-ray of gamma ray inspected, because they were doing gamma, PG, proton is gamma ray. Next. So here a typical Zanes of Fe edge would look like this. Now what are these things? I wanted to see the shift of from the main metal. So the main metal is in black, the remaining are all shifts. So what synchrotron does, it can measure the small shifts in your spectrum. And why that is required? Because it's different for different oxidation states. For Fe2+, it may be different. XRF cannot measure oxidation states. It can only measure whether Fe is there or no. Whereas Zanes and exaphs can measure the shift. It can tell you whether it is 2+, 3+. So that is required for many of the material analysis. Next. Here again you have for zinc. Next. So conclusion is it can be studied and pixie and Zanes, and it is a good alternative. Next. So I have also studied some mineral by radioisotome and synchrotron. See, I told you, whenever I get a sample, I generally use all the facility. So I do it with my XRF. I do it with synchrotron. I also use pixie. I have done some rare earth in forensic samples, in ink samples. And I don't know whether I bought it in my slides, but they were very beautiful spectra, LX rays for the pixie. Next. So this is some of the mercury, and again I said herbo samples, Ayurvedic. They wanted to measure the arsenic and sulfur. Next. So this is how you see the presence. Next. The exaphs for mercury and arsenic, because that was supposed an unwanted element. How to interpret, I didn't know, but this is how they are different. Next. So I don't want to read the whole thing. Next. So conclusion is, unfortunately, I have done some very good work on gemstones. Gemstones is, we cannot break it. Okay. And I found out by XRF that the synthetic ones are different from the natural ones. And the main thing is natural has Fe, large amount, and synthetic doesn't have one thing. Second thing, I did by pixie also, and I got very beautiful spectra with the pixie. And again, I talked about the ink sample. So I request, if you all are really interested in my work, type my name in Google, get my publications, or you can just write gemstones, Dr. Daisy, you will get the paper. They are very beautiful. You can plan your experiments for synchrotron and read out what is possible and contact the right person for that. If you have a problem, do contact me. Even my phone numbers are given in academia and all my phone numbers. So you can contact me. Or Sharma sir will help you for that. So what I mean to say, it is a physical, XRF is a physical phenomena involving interaction of X-rays with matter. Most of the applications of XRF are in areas outside physics. We have environmental chemistry, food products, quality monitoring, etc. They require special knowledge of chemistry, spectral interpretation, calibration, sample preparation, etc. It is not mentioned in 99% of the undergraduate chemistry program in US or in India. So I'm not here to sell XRF, but I'm here to tell some of the good merits and merits of X-ray emission techniques. Next. So my lecture will hopefully encourage wider dissemination use of XRF in undergraduate chemistry, biochemistry program, demonstrate its potential as a means for teaching concepts such as spectroscopy, sampling, qualitative and quantitative analysis, and elemental composition, analytical chemistry, environmental chemistry, independent student reach research projects. Next. Thank you for your time. You may be free to ask questions if you have.
Ma'am?
Yeah.
You spoke about elemental analysis of various things.
Of
various things.
Yeah,
You said even medicines.
Yeah.
So as we are a nation of 1.6 billion people,
Hello.
and over a period we have seen a drastic shift in the food pattern, what we eat right now. It's totally laced with chemicals, and because they use herbicides, pesticides, all those chemicals which are otherwise not required to to increase the yield. And over a period we have realized that we have intrinsic issues with our health now. Everybody is pushing towards cancer and kidney failures and all those sort of issues which we are facing right now. Somewhere they are pointing towards some major troubles in what we eat right now.
Yeah.
Even the food, the milk products which we eat are laced with chemicals and preservatives. So as far as your this entire talk was concerned, I am a little more concerned about whether these technologies which you said that you have handled devices which can do the trace mineral and trace element detection, are they viable to be used in market today?
Yeah, actually.
I am asking about the cost efficiency and the cost consciousness.
Okay, I will tell you. Now see, the last instrument which I am talking about was a handheld XRF. It's very easy to handle, and that is why it is called handheld. Means it's like a gun. You can actually go to your product and do it. It costs around 15 lakhs. So don't you think 15 lakhs is a small thing for a company to buy? And after I have used, so many have purchased. So many people. In fact, I thought I will buy one for my personal use and do this. But I'm not very fond of doing business. I like to help students. That is my duty. That is one thing. And see, that is why I always say natural things are better. For any, if you have a swelling, you should put haldi. I have done work on curcumin, and that is the best thing. So oil, coconut oil. So you have everything in the nature. Why do people add things, chemicals, to make you sick? So nowadays it has become very easy to make somebody ill. So that be careful with that. That's all. I use minimum medicines, even creams also. Whatever people facial, they have a lot of ads. It spoils the skin over the period of time. I never use a single cream on my face. Okay.
Can I say something?
Yeah, please.
We can develop a low-cost equipment. Earlier, Professor Vijay sir has planned 5 years ago. We had a plan. This device, which Madam is seeing, costing around 15 lakhs. We are planning to produce in, I think, around 6 to 7 lakhs.
Yeah.
6 to 7 lakhs. Only detector is. So we can do it for Indian Air Force. We will be in touch. We will send send you the plan exactly. I have the documents with me with on which we were working, Professor Vijay and me. We have prepared a document to be submitted as a project to the DST Government of India. So वो उस वक्त नहीं हो पाया, तो देखते हैं we have something for regarding this.
Thank you.
I have little interest in this food side also. At times in my free time, I study about it. So the problem over here is we have a policy paralysis stage. In a natural, organic, or whole, these three things have got a different definition if we ask about US FDA regulations. But as per FSI, they are blood. So people make
Talking
do use
about,
of.
see, I don't know about the general this, but personally,
Sir,
are you worried about your own health? If you
Obviously.
are, take precautions. Simple. Don't use minimum medicines. Use minimum creams. All this is carcinogenic. I am advising. Okay? The secret of my fitness is I don't take any medicine. I am diabetic, no doubt. I take one tablet in the morning. That's it. I will not take anything else. I am very scared of medicine.
Sir, Yogesh sir, once we reduce the cost of these testing equipment, so in a longer run, it would help in maintaining that standards which are required, which are being sidelined as of now because of the cost involved.
Yeah, correct.
I hope this would be for mankind, it would be one of the most
Correct.
usable technology which we can do, sir. Thank you.
You want to say something?
मैं आपसे गुजारिश की थी एक छोटा सा
Ghana?
गाना.
See, I do not want to boast myself. Whenever I got free time, if anybody asked me what I did other than reading, I would sing or hear songs because it freshens your mind. You start having good thoughts, good emotions, love, and that is better, no? Why we think of the negative things and all that? Okay, people start blaming that one. I'm like this because that one is like this. Why you blame somebody else? You are responsible for your own life. Okay, I will sing a small prayer song. My songs are on YouTube. If you can just type Dr. Daisy Joseph, you have 25 songs written by my husband. 10 are Malayalam, the 15 are Hindi songs. Actually, in BRC, I don't know, I would say whether I am a scientific singer or singing scientist. So I said I am a singing scientist. तुम ही हो माता पिता तुम ही हो बंधु सखा तुम ही हो माता पिता तुम ही हो बंधु सखा तुम ही हो साथी तुम ही सहारे कोई ना अपना सिवा तुम्हारे तुम ही हो साथी तुम ही सहारे कोई ना अपना सिवा तुम्हारे दया की दृष्टि सदा ही रखना तुम ही हो बंधु सखा तुम ही हो माता पिता तुम ही हो बंधु सखा तुम ही हो. Thank you.
तो हमारे वीसी सर भी मैडम के टॉक को लाइव सुन रहे हैं और मैं भी सर से फोन पर वी प्रेज्ड मैडम का जो टॉक था, उनका मैसेज आया मेरे पास, वेरी रिच, वैल्यू एडिंग एंड इंसाइटफुल एक्सपीरियंसेस. तो मैं एक बार उनसे आपको फोन पर, आई थिंक उनका फोन आ गया है, सबको सुना देते हैं. सर, you can say a few lines to ma'am and the audience. Sir. जी sir, it is with you. Yeah, it is, sir.
It is on the speaker.
No wonder India is fortunate to have a galaxy of such committed, dedicated scientists in the country. We know we are in the safest possible hands when people like ma'am are there ruling the roost. It was really enjoying, it was really a treat to listen to her. Very insightful, very valuating, and very enriching session all through. Adding to those scientific interventions, her personal experiences, her personal way of growth is definitely going to inspire the young generation, not only young generation but us as well. And topping it all, the value system that she has presented through this Tumio Mata, Tumio is such a mesmerizing thing. I, on behalf of all of us, express our deep sense of gratitude to you. You wanted me to attend to your session, so I requested you guys to provide me a link so that I cannot miss out on any word that you say. And it was really a treat to listen to you. Thank you so very much. Thank you so much.
Thank you, ma'am. It's wonderful. You got a very positive comment, and our discussion was really good. I hope you enjoyed this session. Yes. कोई सवाल पूछना है लंच के टाइम, ठीक है, मैडम, please. Can I invite the next speaker? Yeah, from NPL, National Physical Laboratory. You know the place? नहीं? इंडिया में स्टैंडर्ड्स के लिए जानी जाती है. Whatever standards we make, okay, testing we like to do on materials, that has to be certified by NPL, okay, National Physical Laboratory. They have got excellent facilities, and we are having a young scientist from NPL. Please share your name.
Myself, Dr. Anuj Krishna.
Anuj Krishnan, and he is going to share his story. So I welcome him. Please.
Good afternoon, everyone. First of all, let me thank Professor Sharma sir and other members of organizing committee, chairman and co-chairman of the session, for giving me opportunity to deliver a talk in this World Conference on Thermoelectrics and Materials. Now, before going to the talk, just a brief introduction. I am Dr. Anuj Krishna, working in CSIR NPL, New Delhi. This is the National Metrology Institute of our country. So, basically, I will be delivering a talk on necessity of Indian reference materials for various technological applications. Now, what is the need of reference materials? Overview of that. What are the reference materials? What are the Indian reference materials? What are the various approaches? How we can get that kind of reference materials? Coming on to the talk. This is the brief outline which I am going to discuss. First, the abstract, glimpses of CSIR NPL. Then what I told, introduction to reference material, Indian reference material, what we call as Bharatiya Nirdeshak Drav, applications of Bharatiya Nirdeshak Drav in various sectors, and the work which carried out in areas of need for food and water waste, B&Ds. Then coming on to the research on single crystals which can be used as a reference standards for optical and thermoelectric applications. Since being a thermoelectric conference, I have some work on thermoelectrics. So how can we use these materials as a reference material for thermoelectric applications? And now the various approaches which can enhance the properties so that can be utilized for reference material in the future scope, conclusion, and technology. This is the abstract. Then coming on to the campus, this is a beautiful campus of CSR NPL. This is the main building, and it was the foundation stone was laid on by 4th January 1947 by Pandit Jawaharlal Nehru. And which is the foundation day of NPL. This is the main building. As you can see, this is located in the center of the tail heart. Coming on to the talk. Now, what is reference material which we are going to focus? Since, as I told, NPL is an MI National Metrology Institute, we are the custodian of standards. So, basically, for standard custodian, we have a responsibility for dissemination of traceability. Now, what is a reference material? Reference material, just in general, there are many characterization equipments if you see, XRD, XRF, or whatever it is. There, different labs will get XRD, XRF, but there will be slight variation in the results. In order to have a uniqueness among them, there is need to be proper calibration of them. So, for that, reference materials are required. Reference material is what? Material sufficiently homogeneous, stable with respect to one or more specified properties which have been established to be intended use for the measurement process. Now, this is the reference material. So, for getting proper result out of any sophisticated instrument, it should be first calibrated using a reference material. Now, what is the difference between a reference material and a certified reference material is that a certified reference material is nothing but it is characterized by metrologically valid procedures and having a certificate of analysis with associated uncertainty involved. Now, what was the need for this reference material and why it came to the fund of Indian reference material? Just I will tell. Now, in India, there are many reference material producers. They are taking traceability from abroad. So, but taking traceability from abroad, it has increased it has to be imported, and there is a cost issues. So, in order to reduce the cost, also there is no proper quality control in India. So, there is a need for reference material, and to reduce the import cost, these Indian reference materials are required. In this regard, a few decades back, activity already started, and under Make in India program, NPL started working on the development of Indian reference material, which is certified Indian reference material or Bharatiya Nirdeshak Drav. You can see this is the traceability pyramid. These BNDs are traceable to the SI unit. You can see from the topmost is the NMI. If you see from there, traceability goes from bottom to down in the calibration of various laboratories. These are basically the CRM producers throughout the world: NIST, USA, Chris Korea, NMI, Japan, BAM, European Commission, many more. In India, we and NPL, we are doing this work. Now, the applications of BNDs, they are widely employed in pharmaceuticals, agriculture, food products, building materials, chemical, petroleum products, metals, minerals, and alloy. If you see agriculture sector, the BNDs which we have developed, if you see, we are taking normal wheat, rice. When the farmers introduce normally the fertilizer, pesticide to grow the crops, there are some levels of toxic elements also go. There should be in the proper permissible limit. For that, the reference materials are required. For that, we have to look whether the rice we have grown or any crops, the particular level of element is there or not, whether it can be taken by human. So that needs to be checked. For that, reference materials are required. Similarly, in case of building materials, petroleum product like sulfur content, and then metals, mineral, XRD, which I told, then and for thermoelectric applications also, which I am going to discuss in the coming slides. Now, need for food and water-based BNDs, which our group is recently working, and under the leadership of Dr. Swarupa Tripathi and Dr. Nahasi, they are the group heads, and I am working as a team member among them. And first, bring on to the staple food crops worldwide. You see, what is the staple food? You can see that is a food which gives maximum calorie intake. And you can see there is a food crop, basically worldwide: rice, corn, and wheat, which makes up to 51% of the calorie intake. So NIST USA has already developed a standard for measuring the level of toxic contaminant in rice and wheat flour, and other NMIs throughout the world are also working. And recently, last year, we have released a rice flour BND under the guidance of Dr. Swarupa Tripathi, he is the leader of this work. And we have worked under this, and we have released on 4 January 2022, which I am going to show in the present slide. Now, how the sources of contaminant enter? Just we have taken, this is the work which we have published, and this is just a review paper, and some of the pictures I have taken from the lab, and this is the UG. How the contaminants enter? Just basically the food chain, from industrial pollutant waste or from the drainage system. They enter to the plants or through pesticides or fertilizers that are introduced into the food. And after that, they enter, and indirectly they enter into the animals, and then after that, by the way of it enters to the humans, and that may have an effect on human health, which I am going to discuss in the coming slides. You can see what are the healths which food contaminations can lead to. You can see the normal small disease too, it can go to up to high extent. You can see it can lead to dizziness, headache, anything, and the acrodania, which is caused by the mercury intake, and this is linked to severe disease. And this food contamination can also lead to heart attack, stroke. You can go deep into the review paper which we have published, and I'm just going to show in the coming slide. This is the paper which we have published, and you can go through this, the need of food reference material, why we have gone through it in deep. It is everything we have given in this. Then this is the initiative which I discussed. This is the rice flour BND which we have developed in NPL, and this is used for determining toxic level contaminant like arsenic, mercury, cadmium, and lead in these basmati rice flour. This was released on 4th January 2022 by CSIR NPL. This is their team, and I worked as a team member under the leadership of Dr. N. Hasing and Dr. Sur. Now coming on to the another aspects of reference material, the applications, that is the water-based BNDs, aqueous elementals, and what we have carried out in this. Now this is required basically, you see in India many people have affected because of waterborne diseases. So cleanliness in water is really very important and is essential for healthy life. So the proper limit of element, permissible limit should be here in this. For getting that permissible limit, again the reference materials are required for particular elements. So each elements, so what we have done several BNDs for that in collaborations with ASHVI. There are two ways, either we go to in-house or there are reference materials. So what we do, we can give traceability. So as NPL can give traceability, and we have developed BNDs for aqueous elemental solution in collaborations with ASHVI Technology LLP. And these are the BNDs which have. And what is the importance of validation, which I will do. What we do for development of this BND, we need to get a source material. Source material purity we use to assess, and that is traceable to SI unit by mass. The source material then can be converted to a batch of production. Complete batch is made of the BNDs. And after that, we take some models out of it, and we can do the validation to cross-check whether the gravimetric value what we have obtained in chemical analysis is in correlation with the instrumental technique. So we go for the validation of these BNDs, and then finally after certification, and this get released as the form of BNDs. You see the stages which are involved in validation is, first we get an elemental solution, then weighing, and after dissolution in acidic medium, then we carry out a chemical analysis using instrument ICP-OES. Right now we are using. Then ICP-OES principle, just what we do, used to calibrate with some standards. Then after that, we take the batch of some particular bottles we take and we analyze. Then determine the intensity and calculate the actual concentration. Then identify the sources of various uncertainties involved in it. And final values we assign it, and the concentration which we get, and then we compare it with the gravimetric value which we obtain. And finally, the certification and the process is carried out, and then the BNDs are released. Now, this was the first part which I told, which we worked as a team. Now, coming on to single crystals as a reference standard for optical and thermoelectric application. This is the part which I'm going to cover in detail, as this is my research area and I propose this work, and we have designed many novel approaches. Since growing a crystal is a difficult task, for reference material particularly to get that normally that kind of crystal that can be used for reference material, it should be of very high quality, because if the crystal is of not high quality, it can no matter, it is not, we can say that it can be used as a reference material. It should be very high quality. Also, there are certain drawbacks of powders or liquid samples which we use as a reference material. To overcome those, we can use as a single crystals as a reference material. Because the drawbacks you can see, if you use powder or particles, they may have a varying part scattering or rapid aging in the powder due to large surface area, which I have highlighted. Also, it will lead to weighing inaccuracies and volume error. But if we go for a single crystal, like thin plate of single crystal, it will give almost similar results with reduced uncertainty and can be used as a reference material for optical as well as thermoelectric applications, which I'm going to highlight in the coming slides. And the approaches which we have worked on to get that kind of crystal, because either to go for high-end technique or to get a modification in the existing design so that we can get such kind of crystals out of it. These are the novel approaches. This is the first one which we carried out. This is the normal melt growth technique I am showing here. This work we have already published. This is the normal melt growth vertical bridgement technique. But to get good quality crystals, we can use this for a reference material production. The normal network technique is what just a bridgement technique. This is a vertical bridgement technique. Here the crystal growth takes place by ampule lowering from a top zone to the cold zone, hot zone to the cold zone. Nucleation begins at the tip and the crystal grows. But here the chances are there. Multi-nucleation chances are maximum. If you go normal procedure, no, most chances are there the multi-nucleation and the crystal quality may degrade and we may not get that quality of crystals. So we have done a modification in this. What we have provided an ampule with support arrangement. You can see there is a support there we have given. And what is that? An alumina bull is inserted in between the ampule and the support. Just what it does, it act like a slow cooling, annealing. You see, this is the, if you see, just pointer, point. Yeah. If you see, this is the normal method. This is the normal vertical placement method, the conventional which we go. But if we do some analysis, either we have to go for high-end techniques or in the existing design. So we have done a modification in design. We have given an ampule with support arrangement. What is just and an aluminum wool is inserted inside. It provides a proper thermal gradient and tries to stabilize the flow of melt in the radial direction. So if the melt is stabilized, so when that it translates from hot zone to cold zone, this lead to proper periodic arrangements of atoms, and then crystallization becomes more perfect compared to this, and we get enhanced properties, better crystalline qualities, and this may be one of the steps that may be used to get that kind of crystals that we can go for reference material production. This we have done, and this I am going to show in the coming slides. Of this, you can see the profile. Here you will get this kind of normal cooling, but here there will be slow cooling. So it automatically enhances the chances of getting good crystals. These results we have obtained. I am going to show in the come. You see, this was the done on organic material benzimidazole, and this was the normal ampule, and this ampule. We have taken a wafer out of it, and then we have examined the wafer using various characterization tools, and then which I am going to show you here. You can. This is the benzimidazole crystal without support. It's a normal conventional procedure, and this is the X-ray almost the same. If you see both the everything is phase. It is in the phase beauty. We have confirmed with the JCP. This is a well-known benzimidazole is a well-known organic material, and we have grown. And this is with support. If you see now, looking onto the it is looking in the figure we cannot see, but after assessing through sophisticated techniques like high resolution X-ray diffraction, you see the quality we assessed, and we observed a wide drastic change in the quality of the crystal grown using the modified procedure. Slides. So slide is stuck. Slide is stuck. No, it is not a video, it's just like. So if you see the HRXLD slide, I don't know where it is. I will show you at the end. I will show you the slide. Just if you show the optical properties, almost we got quite good transmittance, but the defects was quite reduced. We have observed it through HRXLD. I'll show you at the last the HRXLD, which is favoring. It has shown a very good improvement in the crystalline perfection. And this was the optical, and this was also confirmed to the photoluminescence. The defect density got as drastically reduced. If you see, the photoluminescence of this was peak due to defects. And but when you go for the modified procedure, we got the intensity was very much reduced, indicating, and it was confirmed through high resolution X-ray diffractometer. And the curve, that slide is not opening. Just I'll show you. It got a very good crystalline perfection, and this method may be adopted for getting that quality of crystals. If we go for some other particular material for growing crystals for reference material, that can be used in, and normally KDP is used as a reference material for optical and NLO applications. Normally, if you show for optic SSG, second Harmon generation, so we can replace material by tuning the properties using these procedures. This is what the work we have carried out, and this work got published in Crystal Engineering Communication. Coming on to the next, approaches to enhance thermoelectric properties in single crystals. This can be future steps for development of thermoelectric reference material, mainly the CPEC coefficient standard, which was normally first developed by NIST USA, and we may try to develop in future in NPL. Now, what is that? This is the another approach. This is the conventional approach, and this what we have done, a bulb-like structure we have introduced in this. What is this? Is here, if you see, the crystal grown here will be having better quality compared to the down, because in vertical impurities settle down. First reason is this: impurities goes down, so crystal quality is better in the top. Also, one more thing: if you give a necking over here, it acts as a with the supercooled volume is small. The probability that single nucleation penetrates from this to this increases. This leads to the better quality of crystal at the top compared to this, and which we have and you can see this one exactly. A similar result was observed with that technique I show. You see, this was the normal procedure. You see many grains are present, but when we grown the crystal using this bismuth selenide crystal, we have grown and we have observed a sharp peak, and also the grains are close. This is also layered structure material, and one more reason. But this quality has significantly enhanced, and this has led to improvement in the thermoelectric figure of merit, not only for bismuth selenide but also for the bismuth telluride. At temperature we observed for bismuth telluride 1.01 and for selenide 0.76. But in case of nanomaterial also, if we go, it is 0.5, which is reported. But in case of the pure bismuth telluride and selenide, we obtained such kind of result. And these were the steps, normal steps, which I have shown we have followed during the work. And this we presented in Indian International Science Festival Young Scientist Conference, and this was also and this work is published in Material Science and Engineering, and subsequently the bismuth selenide work also got published in IUCR. You can go in deep in this work how this approaches. This is the main which I wanted to show in the benzoate. Slide is not opening, but you see the similar results are observed with that technique also. But these approaches may be used to enhance the crystals. We are trying our best to get that kind of crystals that we can use for reference material protection, particularly for CPEC coefficient standard. Normally, if you procure a wafer, in India crystal growth, if you procure, it is a wafer we can procure, but that is not it. But a homegrown wafer can be used as a reference material, that is also a task. So we are trying the best to get that kind of wafer using existing by modification in the designs. Then this is the third approach, which we have applied onto the solution grown. Normally the solution grown crystal does not have the kind of quality, but still the chances are there we can improve by proper some annealing or something. So here what we have done, we have given a shock waves to the crystal grown. This was an LS Corby crystal. This recently one of my students has done, and we have given shock waves. Shock waves are the pressure waves which we apply using technique, and then we give the shocks. What is the? It produces a thermal in the waves inside it. Shock waves, the pressure waves. So some heat is generated, and this led to orientation in the crystal. So when we examine through the instrumental technique, if you see the HRXLD before shock and after shock, the quality is improved. Here the FWHM is quite low and compared to this. And also if you see the transmission for the pure is this at zero shock, it's the pure material, the grown. And after that, when you have given the maximum shock, it is increases and then it is decreased. But we see the effect of shock here can be seen that the quality is improved, and further you can see the PL intensity has also go down, the defect density is reduced, and the non-linear third order optical coefficient has also enhanced indicating its uses for optical switching applications. So this can be one of the approach that we can use it for reference material protection, that kind of crystal. So these three approaches which we have designed and we are trying to incorporate with other materials so that we can get such kind of crystals over here that can be used for reference material being NMI. So
is mechanical or thermal?
Mechanical shock, but this mechanical shock, sir, we used to give different match numbers. Yeah, through yeah. So what it does it when we give the shock, first shock also we have observed that even after the 12 shocks, 150 megapascal shocks, the crystal does not break, and the quality is enhanced because one reason that we have observed maybe because of the heat produced, they lead to reorientation inside the boundaries, and then the crystalline quality is increased. This is we have observed through HRXL. You can see this result here, and this it is not clear here, but the full width and half maxima here is quite reduced. It is if you see the spread, you can see spread is very small, minus 50 to plus 50. I think this time converted, and here it is more spread. The quality is very much enhanced, giving a shock over here. So this is the third approach we have carried out, and these are novel that we have done, and we are in the process to use them to get that kind of crystals that we can use it for some thermoelectric or optical applications. Like CPEC coefficient standard, which we told, if you procure a wafer from outside, it may be costly. We have already wafers from, so in homegrown wafers can be used, and we can make reference material out of it. This is what we have carried out. Then, coming on to the conclusion part of this, development of certified reference material traceable to SI unit at NPL and at other RMPs in collaboration will bring a paradigm shift in a socio-economic fabric of the country through quality control assurance for export, import, and domestic consumer product in every sector. This will definitely reduce the cost also, and it will make India a self-reliant country, and we can develop our own reference materials that can be used throughout the country without depending on the other countries. Also, the approaches I discussed, which can be used for the crystals, normally advantage over the powder and the liquid materials, because I have told what are the advantage of crystals over the powder. So this can be utilized to get that point of crystals that can be used for the development of reference material for optics and thermoelectrics. My research team working with me. These are the 3 students which are working. For any interested students or any ideas, if you want, you can contact me. This is my mail ID. This is the LinkedIn profile. All the details of work which we are carrying out, you can. And this was the admit we presented last year in NPL. This is my team, and we are working under the supervision of Dr. Nahasi and Dr. Surupada. They are the group head. And thank you so much for the attention. This is the acknowledgement. Thank you, Professor Sharma sir, other organizing committee members, chair of the session, and to our directors, sir, Professor Venu Gopalachandra sir, Professor Reena Sharma, head HRD, Dr. Nahasi, Dr. Surupada Party of Project, Dr. N. Vijayan sir, he is the head of in-house BND group, other technical officers, staff members, and my students for their cooperation and support. Thank you so much. Just for one line, if I say for some students, just one Hindi poem we have written, just 2 lines. We are allowed. Just I have delivered this on Vishwa Hindi Divas recently in NPL, so I just wanted to. मन हार न तू, जीत अकेला ध्येय नहीं. मन हार न तू, जीत अकेला ध्येय नहीं. I'll tell you the explanation. आंधी कितनी आती है, तूफान कितने बरसते हैं, पर्वत भी हिल जाते हैं, पेड़ों के ठूंठ उखड़ते हैं. कर सामना तू, छिप जाना तुझ पर देह नहीं. मन हारना तू, जीत अकेला ध्येय नहीं. नदियां निरंतर बहती है, सब कुछ बहा ले जाती है. सोम भर का भी देखो, पत्थर गला ले जाती है. चंचलता छोड़ना तू, धैर्य इतना भी है नहीं. मन हारना तू, जीत अकेला ध्येय नहीं. चांद सूरज रुकते नहीं, हार कर यूं झुकते नहीं. हौसला बुलंद करना अपना, जो ठहरते हैं वो उठते नहीं. खुश रहना सीखना तू, दुख का पानी पे नहीं. मन हारना तू, जीत अकेला दे नहीं. मीन्स जीतना एक अकेला हो नहीं उद्देश्य. It's opportunities should be taken, and all the students are encouraged to grab each and every opportunity. Every time it is not winning, losing is also the thing that you have learned something, and in future you can do something. This is the thing, and with this I want to thank everyone for listening to my talk, and students may contact me with you anytime. I can come. Sir, also anytime can. Thank you so much, sir. Questions?
Main objective of the institute which you are fulfilling. Are there questions? Which Sohan bhai, please. नाम बताएं.
I am Vivek Kumar. So, what is the reason behind your soak method that is getting better crystals?
Actually, what I told you, the shock, what we have, shock are generally the pressure waves. So when we give the shock, at some intensity, low intensity, there may not be change. But when we are going to high level extent, 150, 1 atom, just I want to show you this. You see, we have given shocks over here. We have given shocks over there. The zero shock, you see, all the properties, if you see, there was no change. But after giving the shocks, the transmittance also increased. In between also, the final one we are showing here, the HR study, the improvement part. Just if you see the other PL and that UV part, if you see, there has been the increase in the transmittance, and meanwhile the PL intensity is reduced for that emission wavelength, and you see the defects because of the decrease in the defect density. So, but at particular, this is for a particular, but after beyond that, it got decreased. But for up to a particular, when we are giving shocks, what is happening is, it is making the reorientation within the crystal, like slow annealing. What you do, you put the sample for annealing. It enhances the crystalline. In the similar way, if we put the material under the shock, we have observed this thing, that the crystallinity is improved because the periodic arrangement of the atom is getting more oriented. The grains are perfectly more oriented, and that's why the crystal quality is increasing with the help of shocks. This is the basic principle that we are observing.
Okay, sure.
घर पे मम्मी करती है काम, बर्फी जमाती है, तो जमाते समय क्या करती है?
So it's very different in that annealing and soft.
Yeah, that is different. We cannot compare those. Yeah, we cannot compare. But this phenomena is recent that we have observed in many metals, not only this particular, many metals we have observed.
Even silicon bridgement technique is used, you know, shaky. Okay.
It has thermal. Annealing generally do PTR around 0.5. We don't know what kind of, but different kind of.
Between that, I think what I'm getting it. So this shock, the molecules are more aligned.
Yeah, that's what I'm saying. Atomic arrangement, that grains are getting more aligned. That intensity of shocks is making thermal heat inside the developing.
Initially, we know what frequency they will align, but just we are trying to
No. Just we are giving the initial from 0 level we are going to high. This is the IMAX. We see at particular level we got a transmittance secret. Beyond that, it start deteriorating the quality. So at we have to study hit and trial. We have to do how much shocks we can give. We don't know material property how this material will be. But other material may behave in some other. But most of the material we have studied, and this is the trend which we have observed over here.
So normally my next question is, what source you are using to keep creating for BND, you are creating different materials. So source basically the natural available, they are synthetically you to
So that depends on the different material. I have discussed about food BNDs. This was the crystal which research we have carried out. The food, what we have, the source material which we have grown in case of rice, basmati rice flour which I discussed. We have taken the seeds from IARI, Indian Agriculture Research, and it was grown in NPL. And the contaminants was used in the form of contaminants during the fertilizer process, and we have then grown, and finally the grown rice was cultivated and refined, and the flour was made, and we have tested using ICPMS, HRICPMS, and then other NMIs, intercompression was carried out, and the level which we have obtained, we have optimized, and we found that this level, that particular level is what we have introduced, we have got, and that has to be with the prescribed limit, within the limit, and we have developed a standard with.
Can we take natural rice as a reference material? It is not pure.
For natural rice is there, but we have to check whether natural rice is grown by some farmers only. But what it happens, sometimes they can introduce pesticide in any. So how much pesticide or fertilizers they are putting while growing the crop? Fertilizers are introduced. How much level of the fertilizer? Because they may not be sometimes more fertilizer. So with them the heavy elements get induced inside, and that ultimately get into the health. So that is checked by other regulatory authorities. So we are the reference material we develop. You can give them so that they can check whether they are in the permissible limit or not.
I have a question here. That was a quite insightful talk. So I wanted to ask that during the Bridgman technique, while you are synthesizing the single crystal, the initial raw material is in powder form or that is in other form?
Powder form, basically the powder form.
Is it pelletized or?
Pelletized also, you can use pellets also, but normally we have taken powder form. It depends on material. You can just, if you have taken already synthesized material, suppose this material, if you have taken already from some sigma or mud, that is synthesized, you can take powder form. Or if you have put some dopant, then you need to first synthesize it, then you will some spark plasma sintering, everything you will do dopant, and you will make some pellets out of it, then we can put that also. But during sealing time, we have to make sure, when we are doing vacuum sealing also, we have to do 10 to the minus 6 torque. The material should not come out. That when you, that is very careful, that you have to be very careful, that material should, otherwise the turbo pump it will enter
And then when you take out the material after, breaking the ampule, so do you need machining for
we need
particular step?
We need aluminum.
That is difficult, I guess.
Yeah, it is difficult. That is the crystal. That's why this approach we want to, because in India we don't have that much crystal growth. It is there in IGCAR, bark, atmospheric bark is the DRC. In LPL we have limited capacity for crystal growth. If we have such kind, either we have to go for high-end technique like Zombrowski or optical floating to get that point, or we can do modifications in the existing design to get that quality of crystal. This is what. Thank you.
Good. Any other question? Nice. एक और क्वेश्चन लेंगे.
This is actually ascorbic acid is vitamin C, huh?
Yes.
Am I right?
Yes, sir.
Okay, then what is the temperature or stability of this material?
Temperature
Because,
is,
yeah, it is
it is at 80 degree, melting point is around 85 degrees.
85 degree.
Yeah, so it is still below room temperature only. It is not high temperature.
And the solution growth at
This
room
solution,
temperature
this
only?
is the solution goes, sir. So
Okay.
normally we are going to 40-45 degree maximum. 40
Yeah,
degrees
maybe this
Celsius
which is degraded.
Yeah, it is
That-
degraded.
Yeah, it did some
80
work
degrees
on
the
it.
melting
Right.
point. So this is room temperature metal only.
Okay.
We have to keep this in a constant temperature bar to optimize at a particular like 30-35 degrees.
What about the reference materials you have tried, like for thermoelectric materials?
Reference material we haven't. This is the approaches we have to work on this material.
haven't tried.
That's approaches which we can.
slide you were showing the bismuth.
Yeah, that was the crystal we have got.
That you acquired from outside or you
No, we have grown. That is a home-grown wafer we have grown. This is the bismuth layer we have grown. I am talking about the, if you purchase wafer bismuth layer outside, that is very costly. But if you can home-grown that wafer we have grown and we have got obtained a similar result that we have we have not shown yet. Reference material production we have to do.
So have you compared these standard materials which are available?
Yeah, yes, NIST USA is already developed a standard reference material for a seabed coefficient for bismuth. It is already there. So we haven't started. We are in the process to start that reference material using our homegrown wafer also. And meanwhile, we have also have the procured wafers also.
So you tried different materials after this?
Yeah, after this because
once the technique is
India we haven't developed that. We are procuring from NIST only. Even this the thermoelectric reference material only NIST has till now has prepared. We haven't worked on it. And here also we have to start. So I have an approach that we are doing a crystal grower, so we can grow that kind of wafers. That's so these are the approaches.
Well, in the solution growth, yes, Mike.
Yes,
Yes. I'm curious to know.
Yes, sir.
You have to keep it silently, without disturbance.
That should be
There the shock doesn't help.
Yeah.
It disturbs
Yes, sir, it
the
is the very
growth. But when you are talking about the effect of shock to improve the crystallinity, it's a contradictory.
Yeah.
Perhaps that was the question.
That is the answer just I will give you, sir.
Huh.
While growing, there should be no disturbance.
Huh.
Should be in the constant temperature. The solution goes if we are going because
Oh,
multi-nutrition,
okay,
supersaturation,
okay.
everything, condition, environmental
Oh, I
conditions.
see. In between you give a shock.
After growth, the crystal, grown crystal, we are giving the shock. We
Shock.
are not giving in between the process.
Oh,
The grown final wafer which we have got, we are giving the shock on that wafer. not-
okay. All right. I will demonstrate. I will demonstrate you in my lecture.
Yes.
Thank you. Thank you. Okay. So any other question? No, we stop here, close for the lunch. And before that, some